Hello, everybody. So in this video, I'm going to be discussing confidence intervals for the population proportion. So let me go ahead and share my screen and we'll get started. All right, so the first thing I want to talk about is what a proportion is. So a proportion is basically the number of successes in a certain number of trials. So like, for example, 35 females out of 100 total people, similar to the binomial distribution that we talked about previously. But it forms a fraction. So a proportion is usually either like a decimal or a percentage. And so population proportions denoted by P, sample proportions denoted by P hat, number of successes is X, number of trials is N. So let's do some examples here. And actually, before I do the examples, let me actually go to here. And so I want to talk about the by hand formula. So there's not really anything new that we haven't done in a previous video. So the video for confidence intervals for the population mean when the population standard deviation is known, I showed you how to calculate the z alpha over 2 values. So I'm not going to do that again. And everything else in here can be calculated from the problem. So all that is in the notes. So you can look at how to do that by hand in the notes. But you only have to do it by hand one time on the project. The rest of the time you'll just be doing it in Rguroo. So in the Rguroo confidence interval calculator. So um, just keep that in mind. All right, so let's go to our first problem here. So assume you're looking to estimate the population proportion of people who are vegan. So we take a sample of 120 people, determine 17 of them are vegans, find the 95% confidence interval, and interpret it in the context of the problem. All right, so we can see here we have 17 successes out of 120 total people. So we're going to be using that information in Rguroo. So this is under analytics, analysis, proportion inference, one population. So factor label is basically the name of the variable. So in this case, we're talking about type of diet. And the success label is what we consider to be a success. So we're considering them being vegan to be a success. And that we're considering a failure to be that they are not vegan. And you could fill this, you have to fill in something and factor in success at a minimum for it to run. You could, in theory, put anything in there, but I always just put like whatever in the context of the problem. So the variable name, what we're considering to be a success, and then what we're considering to be a failure. And then my sample size is 120. My number of successes was 17. And then it was 95% confidence, and you always check large sample Z for these. Hit the eyeball. And so my lower CL and upper CL make up my confidence interval. So just as a reminder here, so the standard error is this right here. This is called the critical value. The critical value times the standard error is called the margin of error, or you can also refer to it as the width. Actually, wait, is it the width? No, never mind, sorry. It is not the width. It's actually half of the width. So it doesn't give you the margin of error for these. The width is the distance from here to here. So it gives you the distance between the two confidence interval bounds. And the standard error is this, like I said. It doesn't give you the margin of error here, which would be this whole thing here. Anyway, but you don't really need that information. You mainly need the lower CL and upper CL. So when you're doing this on a quiz or a test, you need to first give it to me in proper confidence interval notation, which is in parentheses with a comma. So 0.079, comma 0.204. And then once you do that, then you will write an interpretation sentence. So let me switch back over here. So my interpretation sentence, we are 95% confident that the population proportion of people who are vegan is between 0.0793 and 0.2041, which were the bounds of my confidence interval that I see here. So we are whatever percent confident that the population proportion, whatever the context of the problem is between 0.0793 and 0.2041, or the bounds of my confidence interval. All right, so let's do another one. Assume we are looking to estimate the population percentage of people who are going to vote for a particular presidential candidate. So percentage, proportion, they mean the same thing. We took a sample of 1,000 people, determined 526 of them are going to vote for the particular presidential candidate, find the 98% confidence interval, and interpret it. So we have 526 successes out of 1,000 total people. So I'm just going to go under basics here and edit it. So my variable here. So what are we talking about in this problem? We're talking about voting choice. So that's our variable. We're considering a success to be that they are for the candidate, and we're considering a failure to be that they are against the candidate. Like I said, you could put anything in these boxes, doesn't super matter. I always just put the subjects of the problem in there though. And then my sample size was 1,000. My number of successes was 526. And then my confidence level is 98%. So I'm going to change it to 98% and then large sample Z. Hit the eyeball. So I get 0.4893, 0.5627. So writing that in proper confidence interval notation in parentheses. So 4893, 0.5627. So you always write it in proper confidence interval notation first, and then write your interpretation. So my interpretation here. So we are 98% confident that the population percentage of people who are going to vote for a particular presidential candidate, you could have set proportion there also, is between 48.927% and 56.273%. So I just took these bounds and converted them to percentages, but you could also keep them as decimals. That is perfectly fine. So we are whatever percent confident that the population percentage or proportion of whatever is between the two bounds of the confidence interval. All right, so let's do something a little different. So this one, assume we are looking to estimate the population proportion of people who played at least one sport in high school. Assume we took a sample of 275 people and determined 60% of them played at least one sport in high school, find the 99% confidence interval, and interpret it. Okay, so this time we're not given the number of successes here. I have the sample size and the proportion or percentage of people who, in that sample, played at least one sport in high school. So I need to calculate my number of successes. So to do that, I can basically calculate 60% of 275. So using my Desmos calculator here, so I can do 0.6 times 275, and that'll get me 165 successes. And now I have what I need to make my confidence interval. So going under basics here, so my variable for this one, so what are we talking about here? We're talking about playing sports in high school. That's our variable. What we're considering to be a success is that they played at least one sport in high school. And we're considering a failure to be that they played no sports. Once again, you can put anything in theory in these boxes. I always just put the variable success and failure in the context of the problem. My sample size here was 265, I think. Okay. Let me double check that. 275, sorry. And my number of successes was 165. And then I see my proportion of successes here comes out to be, it clicks off of it here, 0.6. So I know that I did it correctly. And then because basically 60% of the sample should be successes based on what the problem said. And then it was 99% confidence, check large sample Z, hit the eyeball. So my confidence interval is, in proper confidence interval notation, 0.529, I'm sorry, 39 and 0.6761. So lower CL and upper CL. And if you ever want to save these, you can always give it a title and hit save as here. And then once you write it in that notation, then you're going to give me the interpretation. So we are 99% confident that the population proportion of people who played at least one sport in high school is between 0.5239 and 0.6761. So we are whatever percent confident that the population proportion of whatever it is in the context of the problem is between the two bounds of my confidence interval, 0.5239 and 0.6761. Okay, so last question here. Assume we're looking to estimate the population percentage of people who are overweight. So we take a sample of 630 people and determine 40% of them are overweight. Find the 80% confidence interval and interpret it in the context of the problem. So once again, I need to calculate my number of successes with this 40%. So I'm going to do 0.4 times 630. That gets me 252 successes. So going under basics here. So my variable name is, so what are we dealing with here? We're dealing with weight. That's our variable or our subject. We're considering a success to be overweight. We're considering a failure to be not overweight. My total sample size is 630. And then my number of success is 252. It's 99. No, I'm sorry, not 99. It's 80% confidence. And then large sample Z. Hit the eyeball. I get 0.375 and 0.425. So writing that in proper confidence interval notation. So you'll write it like this first in parentheses, and then you'll give me the interpretation. So the interpretation, we are 80% confident that the population percentage of people who are overweight is between 37.5% and 42.5%. So I basically just converted these to percentages, but you can also keep them as decimals. That's totally fine. You could also exchange percentage with proportion. Percentage and proportion are the same thing. Any of that is fine. So we are whatever percent confident the population percentage or proportion of whatever is between the two values in our confidence interval. And that is it. So that is confidence intervals for the population proportion. If you have any questions, please feel free to reach out.